Hello and good afternoon, CTS267 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this afternoon's video tutorial is going to be a quick video tutorial and solution set on activity, which is the Polona Bank number 2 set of trouble tickets, which is challenge number 14. So let's kick open the scenario here and let's see what we're going to be working with. And looks like we have it all in one big window here. Okay, so we've got branch 3 configured to summarize the branch 3 network. HQ still sees individual entries. So again, we know that branch 3 was running EIGRP in the previous activity, so there's a very good chance that it still is. And so this is an issue when you either don't have the summary address statement for EIGRP, or you may not have it applied on all of the interfaces where it needs to be applied, or it may not even be on the right interface. And so those are really the two things that come to mind here. And again, so from a troubleshooting perspective, this is kind of, we're shooting from the hip as we see these things, and then we'll work our way through. PC0 does not have internet connectivity through IPv4 or IPv6. And then we've got branch 3 has lost IPv6 internet access. So branch 3 is definitely having some struggles here. And then PC0 at the headquarters office. So we've got customer documentation. I'm scanning through here. So there's our internet connectivity address, and that's the one I'm looking for. Let's make a note of that. 209.165.201.45. And then 2001 DB8 D1A5. And then C92D. Boy, they certainly did not make it easy here from the IPv6 perspective. All right, so we know that branch 3 is configured to summarize, but let's get in here, let's dig in and check it out. So again, when I go to click on branch 3, you'll notice I'm unable to connect. So chances are, when we look at the job aids, we may be in a scenario here where we're going to have to connect to branch 3 remotely, and yes, we're going to have to go from the headquarters. And so branch 3 is 192.168.3.101. So let's get onto the HQ router here, and then let's telnet over to 192.168.3.101. All right, we'll get our password in here, and let's go from user exec to privilege exec. All right, let's go ahead and say show IP. Or actually say, let's see, let's do this here. So we know that they should be doing summarization, so we're going to take a look at the interfaces, show IP interface brief. We've got Ethernet 00, which is the underlay interface, and they're probably, and you can see, boy, they've got quite a few loopbacks here. And then we've got tunnel 3. Now the tunnel address, right, this is how we're tunneling, and this traffic is encrypted last time we looked at it. If we were to say show run interface Ethernet 00, you can see that here's the IP address. We're even doing NAT on that interface, but traffic that is going over this interface, we've got this CryptoMap VPN here, and actually we can see what the issue is already. So when we take a look at this, right, this is the underlay interface. So this is my internet facing physical interface, right? So this is who I'd be connecting to my service provider, right? Like AT&T, Verizon, Comcast, whatever the case may be. And this is considered the underlay interface. The tunnel interface is the overlay interface, and that's the interface over which we're exchanging the routing information. And so how do we know that? Well, if I was to say show IP EIGRP interfaces, you can see all the loopback addresses are in here. Ethernet 01 is in here, and the tunnel interface is in here. But what don't we have in here? What interface is not in here? Exactly, Ethernet 00, because again, that's the underlay interface. That is our connectivity to the internet, right? But all of the traffic between branch 3 and the headquarters office is coming across this tunnel interface. If I was to say show IP route, we would see that, again, you can see here that the headquarters headquarters office is redistributing its OSPF routing information into EIGRP. And if we said show IP EIGRP neighbors, you can see that that is who we have the neighbor relationship with, and it's over the tunnel interface. So this looks like a case of show run interface Ethernet 00 of simply the summary address statement being placed on the wrong interface. So let's go ahead and get into global config interface Ethernet 00. We're going to say no IP summary address EIGRP 100. Whoops, sorry. EIGRP 100 172.16.0.0 16.0.0, and it's a /16. So do show run. And now I don't believe we're going to see a bounce here. Typically, you'll see, I shouldn't say a bounce, a soft reset when we put the summary on, right? So it's not a hard reset. It doesn't take down the EIGRP adjacency. But again, this interface, there is no adjacency over this interface with anyone else. So let's say do show run interface Ethernet 00. Let's make sure that it's gone, and it is. And so now let's get into interface tunnel 3. And let me see, do show IP interface brief. Are they looking for, yeah, 1, 2, 3, 4. So we could do a more restrictive, and that may have been part of it as well. Although that is going to be a monster amount of work. But let's go ahead and do it, right? So I could slap 172.16.0.0 and do a /16 summary. But if the requirement is along the lines of the most accurate summary, right, what would we have to do? Well, we'd have to break down, we'd have to find the interesting octet, which is our third octet here. And interesting in the sense that that is the octet that is different, right? The first one going from left to right, that is different than the other addresses. And so what we'd have to do is break it out into binary. And so we know that 2 in binary is that. 3 is going to be 0011. We've got 4, 0100. 8, 1000. 12 is going to be 1100, 13, 1101, 14 is 1214. We've got 15, and that's going to be 8, 12, 13, 14, 15. We've got 16, so now we're over here into the next nibble, which is the 4 bits. We've got 17, 001, 18, 16, 18, 19, so there is 18, 19, and then 20. So 16, 20. And so when we look at this, we can see, right, if I was to fill the zeros in here, where is the last bit position where any of these match? And you could see it would be here, right? And so here's the nibble boundary right in there, because the last 4 bits, that's a nibble. So when we take a look at this here, we can see that we've already got 8 bits that match there, 8 bits that match there, and now here we've got 9, 10, 11. So 11 bits that match in addition, oh, I shouldn't say 8, 9, 10, 11, 3 additional bits here. So it would be 11, and then 8 would be a /19, right? So the subnet mask is going to be a /19. And then when we look, do we have a value that is in the on position over here that matches? And we don't. So we end up with a 172.16.0.0 /19, which might be why they went ahead and just did it down to a /16. So a 19 would end up being what? What would be the dotted decimal subnet mask? 255.255 dot. And remember, if it's a 19, that means we're borrowing 3 bits. So 128, 192, 224, so 224.0. So this would be our dotted decimal notation. This gives us the most accurate summary, right? So we'll go with this and we'll see what happens. And so it's a /19, 224. Let me clear the screen here, and I'm going to need to remember that. So let's get into the, if we're not already, let's make sure we're on the Tunnel 3 interface. And now we're going to say IP summary address EIGRP 100 172.16.0.0. And now we're going to go ahead and pinch it down to 224.0, and that gives us that /19. Now, remember, back on the HQ router, I don't believe I can open multiple windows. No, I can. It's going to take me back here. So we probably should have taken a look to see that we're seeing all of these individual members of what is going to be our summary, right? So we're seeing all these individual prefixes. And what should happen when we hit enter here is when we go back to the HQ router, and there is that graceful restart that I was talking about, right? And so it's just basically a refreshing of the routing information that does not take down the EIGRP adjacency. If I was to come back with a do show IP EIGRP neighbor, we can see that we've been up for 24 minutes and 34 seconds, right? If I run that command again, you'll see that the timer is just counting up. But the key takeaway here is that this soft or this graceful restart, because of the summary address advertisement, it does not tear down the EIGRP adjacency, right? So this is something that you could do and be relatively confident that it's not going to cause that big of a commotion in the environment. So let's go ahead and say do show IP route EIGRP. And let's see what we've got here. We should be able to see the summary now, again, which was not in the routing table before. And here it is. Not only do we see it, it is the only EIGRP route that we see as not external. Remember this DEX, right? The administrative distance of 170. These are all external EIGRP routes. They've been redistributed from OSPF into EIGRP. And then we've got this, right? So here it is again. This is our internal EIGRP route, but it's the summary, right? So there's our summary, but what is the next hop for the summary? Null 0. And so remember, this is a great reason as to why we want to be as accurate as possible. If I were to say 172.16.0.0 /16 is the summary, I'm representing all networks that begin with 172.16, right, all the way up to 255.255. So we probably don't want to be advertising that. There may be a use case where you do, if you're certain that you're never going to use 172.16 anywhere else other than branch 3. But we wanted to be a little more accurate. And that's what this null 0, and again, I've done a supplemental video on the route to null 0. And so what this means is when routing information, right, or I should say when traffic comes into this router, remember, branch 3 is now a term that you commonly hear used as fronting, right? So branch 3 is fronting or pretending that, hey, if I'm advertising out that if you need to get to anything in the 172.16.0.0/19 range, come to branch 3 because I'm your destination. However, we know that that's not true. I think we saw that I don't think .7, 172.16.7, I don't believe that that was one of the loopback addresses. So it clearly falls within that range. And so here's a case where branch 3 is saying, yeah, I represent all the 172.16s in this /19 range, but it doesn't actually have more specific routing information for all of what would be those member prefixes in this summary range. And that is what the null 0 route, or the route to null 0 takes care of, is that if and when traffic comes in, and let's say traffic is coming in, right, because the headquarters says, yeah, branch 3 says he knows how to get to 172.16.7.0. Traffic gets here to branch 3, and branch 3 looks up in its routing table and realizes, yeah, I know I'm advertising that I know how to get to the 172.16.7, but guess what? I don't actually have a more specific route to get there. So where's that traffic all going to go? The bit bucket, right? To null 0, or you'll sometimes hear it referred to as dev null in the Unix world, right? It goes to the bit bucket. And that's what this null zero entry is for here. So very important, because this tends to throw learners off. Is they see this and they see, well, wait a minute, it's sending all of my traffic to null zero. No, it's only sending traffic to null zero for which this router does not have a longer, more specific match. So if I was to clear the screen here, and we'll leave our conversation of the route to null zero, do show IP route. So take a look. And actually it did have the 7, I apologize. So what doesn't it have? It's got the 1, 2, 3, 4, 5, 6, 7. Yeah, so it could be 18, 19. So you could say the 21, or is it, everything's pretty tight? 1, 2, 3. I thought it was missing something here in this run up, but it doesn't appear to be missing anything. So, but if it was missing a more specific member route, so if traffic showed up here for 172.16.21.1, what would happen to that traffic? Exactly, that traffic would go to the bit bucket, because we don't have a longer, more specific 172.16 prefix that can get us to that network, and that's that null zero route. So now, let me go ahead and quit here, and let's exit out. And let's get over to the headquarters router, where when I say show IP route EIGRP, now we see the summary, right? So here is that 172.16, right? We've got our /19, and how do we get there? We're learning it from the neighbor 192.168.13.1, that's branch 3, and it's out tunnel 3. And so again, the issue here was that the summary was applied, but it was applied to the wrong interface. It was applied to the internet-facing interface. It wasn't applied to the tunnel interface as it needed to be applied. All right, so that takes care of that issue. Let's come back here now and let's keep charging here. We've got PC0 does not have internet connectivity through IPv4 or IPv6. All right, so troubleshooting methodology. We've got this end-user PC here. All we know is it has no connectivity. So first things first, let's do a bottom-up approach. Let's check and make sure that the interfaces show IP interface brief. Let's see what status they're in. So we can see here that this is in an up status. And then let's say show IPv6 interface brief. Right, so working our way from the bottom up. All right, so we've got 2 addresses and everything looks good. What about a show run interface Ethernet 00? All right, so we've got a /24 here, and so let's confirm the problem. So everything looks up here. Let's see if it's going to be somewhere else. Maybe it's a routing issue along the way, an ACL of some kind. So the addresses that we have, let me look at the notes real quick. 209.165.201.45. Do I have connectivity? I clearly do not have IPv4 connectivity here. And let's go ahead and check on IPv6 connectivity. And this is where we're going to ping this monstrosity, 2001:DB8:D1A5:C9:2D::1. It couldn't just be like 2007::5 or something like that. So we're getting the U, which is telling us unreachable, right? So we've got some sort of problem. Well, let's do this. Let's take a look one more time at the diagram here. Can we get to the HQ router? Show IP interface brief. Let's see what we've got here. Let's see if I can reach any of these addresses here on the HQ router. I'm going to try the 209.165.202. So let's ping 209.165.200.2, and let's see if I can get to that interface. All right, so that's not working either. So let's go ahead and kill out of that. All right, so the next thing that we need to take a look at, show run interface Ethernet 00. Now that we know we've got an IPv4 address, and we know that we have an IPv6 address, yet we're not actually able to connect. Let's move to switch 1 here. And let me look at the job aids. Again, trying to stay bottom up, so we're going to make our way up to the switch. And I'm looking for anything that gives me some VLAN information here. And maybe we don't get it. In PC0, which is the PC we're on, is showing that. All right, HQ advertises the IPv6 default route via RIPng. So we're not there yet. And do they not give us any VLAN information here? Or is everything in is everything in VLAN 1? I think it was in VLAN 1 before. So let's say show VLAN brief. Yeah, okay, so everything is in VLAN 1. Let's say show IP interface brief here, and let's see all of the ports are up, and there is VLAN 1 in the VLAN 1 IP. So can I ping 192.168.0.100, which is the PC plugged directly into this port, or into a port here on this switch. And that's interesting. I can't even ping the PC. Let's see if I can ping from the PC to 192.168.0.70, which we're listing as the VLAN 1 IP here. Of the switch. And let's see what happens here. So that's clearly not working. Do we even see the MAC address here? So now we're going to dig deeper. Show MAC address table. And over here, let's say, wait for the ping to time out. Show interface Ethernet 00. So my MAC is Charlie 0, so it's Alpha Alpha 00. So there it is. Alpha Alpha 00 comes in on Ethernet 00. Let's say show run interface Ethernet 00. All right, so everything looks fine there. The interface is up, and the MAC address is there. So then why is there a VACL? Show run include filter. Okay, so there's no VLAN access list. We should be able to ping. Well, let's come back over here to PC0. Can PC0 ping itself? 192.168.0.100. Okay, well this is odd, because typically if a device can't ping itself, show IP route, default gateway is 0.1, show IP interface brief. Let me make sure I'm not looking. Oh, okay. Yeah, so I am definitely not dyslexic, but that is definitely tricky right there. So the bottom-up troubleshooting approach has yielded the correct result. I couldn't ping myself, but that's because when I looked at this IP address earlier, I looked at it, I thought I saw 192.168, and again, I'm sure there's some sort of visual cue type thing that you could use to describe when you look at that and you think it's 168. The preconceived notion maybe that I assumed it was going to be 192.168, and it clearly was not. So went down the rabbit hole, but again, the nice thing was with it was sort of a circuitous rabbit hole where, you know, we get down from the bottom up troubleshooting method. It brings us all the way back down the rabbit hole to look at the interface to say, wait a second, why can I not ping my own address? And now when it pops up, because I'm more in tuned to, hey, something is wrong on this interface, I'm actually seeing this. In fact, when I said show run interface Ethernet 00, yeah, I just went right by it thinking 192.168, that was correct. So there is the IPv4 issue, or one of the IPv4 issues. Let's get into interface Ethernet 00. The IP address is wrong. So IP address 192.168.0.100. We're going to go with the /24. And now can I ping out to 209.165? Well, actually, we should probably even start. Let's start here. 192.168.0.70. Can I ping the SVI on the switch? Fantastic. Can I ping 209.165, what was it, 201.45. And we got to get that do in there. And we can. Okay, great. So what was a very simple issue that I probably looked at immediately, I simply saw the second octet as 168. Again, assuming that, yeah, 192.168, and didn't even pick up that it was 192.186. All right, so there's our IPv4 issue. The IPv6 issue, we saw the U coming back, telling us that we've got some sort of what could be a routing issue. So we're going to say, do show IPv6 interface brief. I'm double checking here. Yeah, so DB8 C0A8, and that looks correct. Let me see. Show IPv6 interface brief. So now I'm all paranoid that it's probably something with the IP address, but chances are it's not. Let's see. Can I ping the :A::1 address? Can I get up here to the HQ router? Let's see what we've got here. So do ping 2001:DB8: C0A8:A::, I can't remember if it was A or 1. Let's give both of them a try. No, so that is not working at all. All right, so now we're going to have to make our way. So we don't have any connectivity. We know that the ports are up here. Let's take a look at router 1. And actually, let me pause real briefly here for just 1 second. All right, so we're on router 1 here, and let's see how far we can get from PC0. Let's go ahead and say show IPv6 interface brief. How about a show IPv6 route as well? So they mentioned that we're running RIPng. All right, so can I get to any of these interfaces? Let's try :100::1 here on Ethernet 01, which, if I'm not mistaken, is that inside, or actually 00. So we'll try the Ethernet 00 IP addresses, and that's just going to be DB8C ::FD. Let's see if we've got any reachability at all here. So do ping, and let me pull that back up and double check that address. COA: FD :FD. All right, so we can reach the what we'll call the inside interface of router 1. Can we reach the outside? And actually, let's step it up here. Let's move up to in the HQ router. We're going to try these interfaces here, which should be Ethernet 01 and 02. Let me double check. Let me make sure I get the right interfaces there. So Ethernet 01 and 02. So it is in fact 01 and 02. So :100::2 and :200::2. So let's see, can we reach those inside interfaces? 100::2. We can, and how about 200::2? All right, so we can get all the way to the HQ router. And again, this is with pings, right? So we're kind of doing the split the difference method here, right? We're trying to cut things in half. So ping seems to be working all the way up to the HQ router, but we're not able to get to the internet. Now, it mentioned that we are running RIPng, and when we looked at, what do we have? Show IPv6 RIP. Let's take a look at the RIP process here. And it is running on those interfaces. And how about a show IPv6 route again? Do we have... All right, we've got a static default route that points to Ethernet 00. And that is about it. So there is a static default. We don't have, I don't see any routing information specific for the prefix that we're trying to get to, that 2001 DB8 D1A5. And that doesn't sit in here. But there is a static. Let me move back. Did we look? Okay. So here's the issue. And if we look at router 1, I'll pull router 2 up. My suspicion is that this is going to be the same thing. Show IPv6 route. So we're using ping, right? We've got connectivity all the way to the HQ router, which tells us that layer 3 is functional up to the HQ router. So that the problem is probably above layer 3 with one of the routing protocols. Well, we're running RIPng. Excuse me, and when I ping from PC0, the traffic is going to come up here to either either router 1 or router 2. In both cases, neither router 1 or router 2 has a specific match for that network we're trying to get to, that 2001 DB8 D1A5 C9 2 Delta. But we have a default route here, a statically created default route. If I was to say show run include route, you can see there is my IPv6 default route. However, these two routers down here, router 1 and router 2, are not learning about that default route. So what do we need to do? Well, we need to come to the HQ router. We need to get into global config, and let's say do show run section RIPng, or that's not, I'm sorry, do show run section RIP. Yeah, so IPv6 router RIP CCNP. So let's get into IPv6, or actually, no, sorry. With, unlike OSPF and unlike EIGRP, where we would do it under the IPv6 EIGRP, with RIP, we're going to do it under the individual interfaces, if I remember correctly. In fact, let me double check. IPv6 router RIP CCNP, is there a default? Yeah, so the default information originates not here. So if I like if I was to say router OSPF1, default default information originate, right? That's under the global OSPF process. With RIPng, IPv6 router RIP CCNP, right? There is no default information originate here. We've got to do it with RIP. We have to do it under the individual interfaces. So I would go into the two interfaces. It was the 01s, I believe, or actually, where are we at here? So on HQ, it's going to be, yeah, Ethernet 01 and 02 on the HQ router. So let's go ahead and say interface range, which we can get to here on IOL. Ethernet 01, actually should be able to do that. Yeah, and all we're going to do now is we're going to say IPv6 and RIP, I believe, and then we should have the name CCNP. No, summary address, sorry. I was thinking about the previous issue. Default information originate. Now remember the difference between default information only and default information originate. If I said default information only, router 1 and router 2 would only see that default route. They would not see other routing information. And actually, this is out the 00 interface. So here, we'll do default only, right? So if I come to HQ, if I say default information only, right? And RIP is definitely not the fastest of routing protocols. And actually, there it is. So we picked it up. And it's actually learning this off that Ethernet 00 interface, which I believe is the, it's facing router 2. So that's why we'll see that. But here you can see all we get is the default route from the HQ router. So if the HQ router had a loopback address it was advertising into RIPng, we would only see this default route right here. Let's check router 2 and see if router 2 now sees that default route. It does. So my suspicion is that we should now have all the information required. And I'm going to have to walk back here and let's see if it's readily available. It doesn't appear to be there. I'm looking for the command I was running for the ping for the address, and by the time I find it, my gut tells me that it would have been easier just to simply type it in. Murphy's Law, right? And there it is. Okay, so We're going to try to ping that address, and now we have connectivity. So the second issue was that we didn't have a more specific match on router 1 or router 2 because router 1 and router 2 were not given the default information from that HQ router. All right, let's take a look at our third and final issue here in this scenario, and it was IPv6. Branch 3 devices lost IPv6 internet access. All right, well, let's go to, and actually we're going to have to telnet again, it looks like. And let me check and see, can you get onto PC3? 192.168.3.100. So let's go to the HQ router and let's say end, and we'll say telnet 192.168.3.100. Can we get onto the PC? Password required, but none set. We cannot. So we'll go back to the branch router and we'll enter the password in. User exec to privilege exec here. And let's go ahead and try to go down the middle. Divide and conquer, right? So here we go. Let's try to ping, unfortunately, 2001 DB8 colon D1A5 colon C9 2 delta colon that is not an address, colon 1, and let's see what happens. So nothing. And let's go from the opposite direction. Let's try PC0 and let's see if we can, what is the branch 3 IPv6 address? Where is it? Oh boy, here we go. And this is not going to make, okay, so auto config for the PC. Let's try the branch 3, has some loopback addresses. That's right, actually we didn't summarize those. But let's give one of these a shot here. Let me write this down. 2000, there's no way I'll remember that. 2001 colon DB8 colon AC10 colon, and we'll just try 0100 colon 1. All right, so let's give that a try from PC0. So ping 2001 colon DB8 colon AC10 colon 0100 colon 1. Do we get anything back? Nothing. Right, so this isn't helping us much. Let's try to trace and see if the trace route helps us any more than this. And we'll let that run, and while that's running, I'm going to come back here to branch 3 and let's see if we can trace our way out of here. So back to PC0. All right, so we make it one hop to colon FE. All right, we get to 200 colon 2, which I believe is router 2. And then we hit this address, D1A5 Charlie 92 Delta colon 1. All right, any better luck from over here? All right, so interesting that we don't even make the first hop. All right, let's do Control-Shift-6. Let's take a look at the interface here. Whoops, Control-Shift-6. Oh boy. I'm hoping that this is not. All right, let's see if we can get over there from PC3. There we go. Or from PC0 here. So let's try to telnet to 192.168.3.101. All right, good. So we'll get back in here into privilege exec. And we wanted to say show IP interface brief. And it's Ethernet 00, but we should be going out, show IPv6 interface brief. We should be going out that tunnel 3 interface. Lots of loopbacks. Or is it just going straight out to the internet? Yeah, no IPv6 addressing there on the tunnel. Show run interface Ethernet 00. Show run interface tunnel 3. Yeah, the tunnel's all IPv4. So the v6 traffic, it looks like it's supposed to go via the internet, I believe, and we have an access list, an inbound access list on branch 3. And that's it. You don't say access class, you say traffic filter with IPv6, and we'll talk about some of the semantics here. So let's say show run, and let's pipe it to section IPv6 access list. Wow. Okay, so it's permitting. Oh, okay. So here's the problem. And this is, there are some commonalities here between IPv6 and IPv4. This has got to be the issue. So you can see right here at the end, we have what's referred to as explicit, because it's being explicitly placed into the ACL, which is at the end of every ACL, IPv4 and IPv6, there's a deny any, right? Sort of your catch-all. And it's an implicit deny any, which means when you say show access list, or show IP access list, or show IPv6 access list, or show access list in the case of IPv4, you're not going to see this, right? Because again, it's implicit. It's implied that it's always going to be at the end of the all access lists. In IPv6, if you put this here, you're actually blocking the neighbor discovery protocol. In fact, you're blocking the router advertisements and router solicitations as well. And so when this gets placed into an IPv6 ACL, we lose all of our layer 2 capabilities with IPv6, that neighbor discovery protocol, which you can think of it like ARP, right? Think of it as sort of like ARP, neighbor discoveries to IPv6 as ARP is to IPv4 in many ways. Because at the end of every IPv6 ACL, what you have is, and again, it's implicit. What you've got is what is it? Permit ICMP, and let me think. Any, and it's neighbor discovery, and I don't know the order. It's neighbor advertisement, and then it's the exact same thing: neighbor discovery, neighbor solicitation, and then you have the implicit, the implied deny IPv6 any. And this, all three of those statements are implicit in every implicit in every IPv6 ACL. These three lines are at the end of every ACL that you create. So when you put this deny IPv6 any statement explicitly in your IPv6 ACL, it would appear right here. In other words, right before you permit neighbor, so I did say neighbor associate, neighbor advertisements and neighbor solicitations, right? And so that's one of the significant differences between v4 and v6. There are a couple other ones, right? So let's kind of talk these out here real quick. That at the top of my head is that in IPv6, ACLs are always extended, right? There are no standard extend. I spelled that wrong. Extended. Having a problem with spelling this evening. So IPv6 ACLs are always extended, and they are always named. There are no numbered IPv6 ACLs, and there are no standard IPv6 ACLs. all IPv6 ACLs are extended and named. And that's one difference. And then the other difference we've already talked about here. At the end of every IPv6 ACL, in addition to the deny IPv6 any, which is the same as that deny IP any for an IPv4 ACL, you have these two additional lines that are trying to ensure that the neighbor discovery protocol, specifically the neighbor advertisements and the neighbor solicitations, and in other words, a sense like ARP. So the advertisement says, let's start with the solicitation. The solicitation says, hey, I've got this IPv6 address. What is the MAC address for this IPv6 address? And then you would have a neighbor advertisement, someone listening on the wire, that says, hey, that's the IPv6 address I have. Here is my MAC address. And this is the mechanism through which IPv6 is discovering that layer 2 to layer 3 mapping. And that's what IPv6 is using, as opposed to ARP, which is IPv4. And so again, this entry right here, being explicitly placed at the end of the ACL, is negating the neighbor discovery protocol. In fact, let's take a look on branch 3. If I was to say debug IPv6, and this is going to go way back, it should be nd, is it in there? It is nd neighbor discovery. So we'll say debug IPv6 neighbor discovery, right? And let's see what ends up happening here. So if I'm on branch 3, let's do this. Show IPv6 interface brief. FE80::0. We don't know. Yeah, I don't know the internet's address, but you'll notice we're not seeing any information at all with relation to neighbor discovery. The address is auto-configured on PC3. So let's just try that. I'll just try this. So let's say ping 2001:db8:. What is that? Ethernet 01. Let me do this. db8: Charlie 0 Alpha 8 340::1, or we'll say 2. And let's see if we see anything with the neighbor discovery here. And again, I may be off on the debug, and it's not IP. Let me try debug IPv6. I don't think it's ICMP. I don't think that's going to help us here. It's that neighbor discovery that we need, and this isn't going to work at all. So I'm going to resolve the issue, and because right now it's blocking that ACL on Ethernet 00 is blocking neighbor discovery and neighbor advertisements. And I apologize. I should have been pinging. Let me real quickly see if we get any different results. We may not. So ping, sorry, 2001:db8:AC. Where is that address at? AC or D1 :D1 A5 Charlie 9 2 Delta ::1. So I'm trying to ping out to that address on the internet, and we get nothing, right? So let's go ahead and resolve the issue here with that ACL. And what is the name of that IPv6 ACL? It is from_internet. Okay, so let's go ahead and get into global config. We're going to say IPv6 access list from_internet. And we're simply going to say, let's do this first. Do show IPv6 access list from_internet. And no deny. And I think we can get it by the sequence number here. No sequence 220. Yeah, so we can pick it off by the sequence number. So if we were to rerun that command, the deny IPv6 any is off of there. So I should see something here, I would think, when we go to do that ping with neighbor discovery. Yeah, we're not seeing anything. And again, it could be that the debug I've selected is not the debug that I'm looking for. All right, but that we've got our IPv6 connectivity is restored. If I go all the way out here and let's come back to PC0, what happens if I try to trace over to one of the loopback addresses on branch 3? We should be able to get there. And let's give it a try here. All right, so then we should get to, I think, what was it, the 222::2, which took us to router 2, or 200::2. And let's see if we can make it over to the headquarters router. And actually, you know what? That's internet connectivity. And so the traffic's not actually going over the tunnel. It's going over the internet. So there it is. Right? We're able to reach all the way over to our destination. All right, well, that wraps up the 3 trouble tickets here. These were some good ones, but again, very common problems that you see. We had the EIGRP summary address statement on the wrong interface, and so you were seeing the member prefixes and not just the summary. We had the next issue, and quite possibly one of the easiest, was the IPv4 address, which was just simply wrong, the second octet. And then we had no default route coming in from RIP, so we didn't have reachability. So we had to do the default information originate under the interfaces. And then we have this, the IPv6 deny any at the end of the ACL, which is a surefire way to guarantee that neighbor discovery and neighbor solicitation are not going to work. And it's bothering me that was not working. And so give me a second here. I'm going to pull up my actual Cisco routers here, and I'm curious to see if, and actually let's do this. We'll say debug IPv6 neighbor discovery. I thought there were more choices. There aren't. Debug ICMP. I could swear that it's neighbor discovery. So let me do this real quickly here. Interface, let's get into the global config first. So conft interface FA00, IPv6 address, I'll just say FE80::1, link local, and yeah. So this is what I was expecting to see. Whoops, I did not want to get rid of that. Let's give ourselves some real estate here. Yeah, so this is what you should have seen. And I was anticipating that this is what we were going to see. Maybe I need to take the interface down and bring it back up. It could have been HQ. We're still over here on connection lost. So let's get logged in here real quick. Yeah, because this is bothering me that this was not working. And it could be IOL, but it's usually not. Interface Ethernet 00. I'm going to put another IPv6 address FE80::, we'll say 999, link local. Oh, actually, let me kick off the debug first. Do debug IPv6 neighbor discovery. And now let's go ahead and say IPv6 address FE80::, let's say 999, link local. And do we get any debugging at all? None. So I'm going to chalk this up to, I'll go ahead and chalk that up to IOU, an IOU issue. But let's come back to router 2, interface fast Ethernet 00, IPv6 address, global config first, conft IPv6 address of FE80::2, link local. We're going to hit enter, and then we're going to jump right back over to router 1, because we should see something here if I try to, let's go ahead and say do ping FE80::2, and we're going to go out interface fast Ethernet 00. And there we go. Right, yeah. So, and this is what I was anticipating we were going to see, because it creates this neighbor cache table that caches the layer 2 to layer 3 mapping information. In fact, we can see that caching table, show IPv6 neighbor discovery. I don't think it's secured. Yeah, that's not what, yeah, there's a cache, show IPv6. Is it cache? No, I can't remember the command. Neighbors cache? Neighbor detail? No, I apologize. I can't remember the command off the top of my head. But again, we should have been seeing these neighbor discovery messages. And what they are allowing us to do is to make that resolution between layer 2 and layer 3, and it gives us that outgoing interface as well. All right, well, this is going to wrap up discovery activity number 14 in the Bank of Polona. All right, thanks for watching, and I will see you guys on Thursday evening.